Hello viewers, I'm Kausalya. Today we are going to solve problem 2 in finding the y parameters of a two-port network. So this is the second method of solving the same problem. So here this is the given problem. So we have two ports, A dash is the input port and B dash is the output port. And now we are going to find all the y parameters by using nodal analysis. In the previous video, we have solved this problem by short circuiting the input port and short circuiting the output port. Right. So by short circuiting one port, we will be calculating two parameters, and by short circuiting the another port, we will be finding the rest of the two parameters. But here we are going to use nodal analysis to find all the four parameters. So here in this case, you see, okay, the same circuit diagram because it comprises only resistors. So now we are fixing the nodes. So generally a node is nothing but interconnection of two or more elements. But here in this case, you see this is one node and this is one node because two elements are get connected. But here we are assuming this as another node to make our calculation easier and simple. Right, with the two nodes we are unable to solve. So here we are assuming this input port as one node and this output port here as another node. You see this node and this node are at the same potential. So even when you mark this as node 2, this is also said to be node 2 only because there are no elements in between and they are at the same potential. Right, so totally we have three nodes, node 1, node 2 and node 3. Now we are going to write the nodal equations. So first at node 1, you see, we have 1 ohm which is connected between node 1 and 2. So while writing the equation, here I1 is equal to V1 minus V3 by 1 because now we are writing nodal equations for node 1. Therefore, V1 should be written first. Right. Now we are writing nodal equations at node 2. So when you look at node 2, you see here we are having two elements which are connected and this 4 ohm is connected only with this node 2. Therefore, while writing equation and the respective current flowing here is I2. So I2 is equal to V2 by 4 plus, and again this 2 ohm is connected between node 2 and node 3. So while writing equation, it should be V2 minus V3 by 2. So this is your equation number 2. Now we are going to write nodal equations for node 3. So at node 3, you see at present we don't have any currents. So the current flowing through this node 3 is 0. And we are going to write the equations. So you see here it is 0 and this 2 ohm is connected only with this node 3. So while writing equation, it should be V3 by 2. And again, while writing equations for this 2 ohm, it should be written as V3 minus V2 by 2 and here V3 minus V1 by 1. Am I making clear? Because while writing equations, you should consider the node which we are considering. Okay, that should be written first. So here it is V3 minus V1 and V3 minus V2. So let this be your equation number 3. Now we are going to solve this equation 3. So here, as a first step, you see I had split down and write the denominator terms for each and individual terms. So here V3 by 2, here V3 minus V1 and here V3 by 2 minus V2 by 2. And I am going to combine the common terms together. So here I am having 3 V3 terms. So when you take V3 outside, the remaining parameters are 1 by 2 plus 1 plus 1 by 2 and here minus V1 and here minus V2 by 2. So once you solve here, you see half plus half makes 1, right? So 1 plus 1 is 2 minus V1 minus V2 by 2. So when you move these terms to the left hand side, they become positive. So V1 plus V2 by 2 is 2V3. So here again I want only V3. So I am moving this 2. So this 2 when moved to the left hand side, it becomes 1 by 2. And finally V3 is given by, I am multiplying this 1 by 2 with the terms inside. So I will be having V1 by 2 plus V2 by 4 is equal to V3. Mark this as equation number 4. Now what is I1? I1 is nothing but V1 minus V3 and now we have calculated V3. So just substitute the values of V3 here. So V3 is V1 by 2 plus V2 by 4. So when you move this negative sign inside, you see both these terms become negative. So here again I have two V1 terms. So when I take V1 outside, it becomes 1 minus 1 by 2 and here minus V2 by 4. So 1 minus 1 by 2 is 1 by 2. So therefore V1 by 2 minus V2 by 4. So this is your equation of I1. Now I am going to compare this equation with the standard equation. So when you compare, you see here what is the coefficient of V1? It is Y11. So here coefficient of V1 is 1 by 2. So Y11 is 1 by 2, which is 0.5 more. Again, when you compare these two terms, here coefficient of V2 is Y12 and here coefficient of V2 is minus 1 by 4. So Y12 is equal to minus 1 by 4 and so here the answer is minus 0.25 more. So here we have calculated two parameters. Now we are going to find the remaining two. So now consider your equation number 2. So here the equation is I2 is equal to V2 by 4 plus V2 minus V3 by 2. So now here we are going to substitute the value for V3 in this equation. So you see here the expression for I2 is given by this. Now we are going to substitute the value of V3 here. So once you substitute, you see here already we are having this 2, right? So this is what I had written, right? So you see V2 by 4 plus V2 by 2 written here and I am writing this minus 1 by 2 here and what is the expression for V3? It is V1 by 2 plus V2 by 4. Now I am going to multiply these terms with this minus 1 by 2. So here it becomes minus V1 by 4 and minus V2 by 8. Now I am combining all the V2 terms together. So when you combine here, we have 1 by 4 plus 1 by 2 minus 1 by 8 minus V1 by 4. So once you solve, here we are getting the answer V2 into 5 by 8 minus V1 by 4. So now again we are going to compare this equation with our standard one. So here in this case, I believe you people know how to take LCM. So be careful while doing this. This is a simple calculation. Now, when you compare here, what is the standard equation? Here the standard equation is I2 is equal to Y21 V1 plus Y22 into V2. So when you compare these two, you see what is the coefficient of V1 here? It is Y21. So here what is the coefficient of V1? It is minus 1 by 4. So Y21 is given by minus 1 by 4, which is minus 0.25 more. And as a next step, we are going to compare the coefficient of V2. So here the coefficient of V2 is Y22 and here it is 5 by 8. So therefore Y22 is given by 5 by 8 more. So that's all. We have calculated all the 4 parameters here. So in the previous video, we had again calculated the same parameters, but the method is different. And here we have used nodal analysis. You can solve the problem by using any method. Okay, any way is correct. So that's all here. If you have any doubt, let me know in the comment section. Thank you.